Hello, chemistry students. I want to demonstrate, so the lab that I have posted or have delivered to you is a series of reactions that you need to write down observations of. So the very first one I want to do for you really quickly, and I just want you to make careful observations. The first one is burning some magnesium, which you've kind of done that. You've heated it in order to have it oxidize. See, it's this, I don't know if you, this perfect silver ribbon. Magnesium is pretty soft. I can tear it just like a piece of tape. Magnesium is used in things like there's little campfire starters with magnesium in that you like shave little pieces of magnesium off, and then if you can light it with a match, it burns really hot, so it's more likely to start your fire material really well. This might be a big piece. This actually might be a lot, so I'm scared. No, I'm not. So I have an evaporating dish. I want something to set the magnesium ribbon on when it starts burning. So maybe I'll put that in a little U shape so it doesn't hang over the edge. When I was a kid, my dad was a welder by trade, and he did a lot of welding at home, not just on his job. We had a farm, and he did a lot of welding at home, and he was really, really good, so he actually would weld for neighbors too. He's still a perfect welder. But welding the outside of welding rods, you know how they say when someone's welding, if you've ever taken a welding class, like you don't look at that, you need to have that face shield on that's really dark so that you don't get welder burn in your eyes. Same thing here. This is going to be really, really bright. So once I start this, I'm going to try I'm not going to look at it. I'm just going to try to look away and get it in my dish. This might be a big piece, so it takes a little bit to get, it has to get really hot to get started. And I've had a little weld burn in my eyes before, so I'm already like closing my eyes. See how bright that is? Like, don't look at it. Super bright, lots of smoke. I have my eyes closed. I have it sitting in there finishing. I don't know if we can get a shot of that. Yeah, it's pretty much embers at this point. I'm going to shut my... I don't need my Bunsen burner anymore, so I'm going to shut that off. So your observations, right, of what you see there. Now I'm going to show you, might be one little piece on the end. I don't know how to show you this. Oh yeah, this is actually okay. See how it's turned white? And remember earlier in the year when we did some of this, you heated magnesium and you took the mass of it before and took the mass of it after, and you saw that it actually gained some mass. It actually looked larger too. See how this has turned to white ash? And it actually is like bigger than the pieces I started with. It's sort of fluffier. It is, it has kind of coated. So even though it's a combustion reaction, we've burned this. If I took the mass, it's very likely that I've gained some mass from that. So on your sheet, you have to, on the page, I'll show you the page that looks like this. So reaction number 1, write down your observations and exactly what you saw, detailed observations. And that's kind of it for the first one. Okay, the second reaction is also using magnesium. So I'm going to tear a piece off. I want a big enough piece. I hope it's easy enough for you to see. And it says to measure out a specific amount of 1 molar hydrochloric acid. I have 1 molar, and it says about 2 milliliters, 40 drops. The amount is really, I'm not going to measure it because the amount is really well, I don't want too much. The amount isn't super significant, except that we want to be able to, I don't know, kind of the ratio of magnesium to the acid is a little bit important. So, all right, and then it says 2 to 3 centimeter strip. Well, I have way more than that. So I have a couple of 2 centimeter strips. But again, for you guys, I just want you to be able to see. So I'm just going to drop it in there. I don't know which background is better. Sorry, it's like mirror. Oh, that's pretty obvious. You can even hear it. I can see a little vapor. Well, I shouldn't tell you. Detailed observations. What do you see? I also will tell you, because you can't observe this directly, but this is very warm. This is very, very warm. So think of back earlier in the year when you did a lab that was a series of metals and a series of different acids. And so you kind of did this already too earlier in the year. You put some magnesium in different acids, and this hydrochloric acid was one of them. You also did like calcium and zinc and copper, and I think iron was the other one. And then you had like 4 or 5 different acids you used. This is really warm, okay? I will tell you, well, maybe I can show you at the end. I'll rinse this out. I don't know if it tells you how long to leave it in there. It just says about 30 seconds. So, so you can, I'm sure you can see, this is, you know, still a lot of reacting going on. I'm going to rinse this and just show you. So this is the magnesium that I reacted, and this is what it looked like before. So I don't know if you can detect, the ones that I reacted are very shiny, very clean. The original magnesium probably had some oxidation on, you know, it's been laying around, even though it's in a bag, it's not perfect. But this, all the oxidation has been cleaned up. So this is very shiny. That's another maybe observation that you could write down. But write down the evidence of chemical reaction that you saw in that one. All right, experiment number 3, a clean, dry test tube. And it says to take a pea-sized portion of something called ammonium carbonate and put in the test tube. So, oof, that was too close. Wafting this, ammonium, a lot of ammonium compounds have a very distinct odor. And if you waft this, it's a really strong, like, urine odor. There's ammonia in urine, and actually it's making my eyes water just having this open by me, so I'm going to close it for a second. Anyway, so that strong ammonia smell, a lot of people would say like, oh, like wet diaper. More people say like cat litter box that hasn't been cleaned, those kinds of smells. When I was growing up, and I'm the second oldest of 6 kids, this is what the diaper pail smelled like. There were always babies in the house, and this was a smell when there was a baby in the house that, yeah, I mean, we had an old wringer washer. It wasn't like how you kids have it nowadays, I'll tell you that. So this is my pea-sized portion. And then we're going to use some, so I have to read the instructions to make sure. So holding a test tube, oh, I have to heat this one. So I'll get that set up really quickly. Okay, so I had to get a test tube holder because it says, if you look specifically in your instruction sheet, it says, use the test tube clamp to hold the test tube and gently heat the test tube in a laboratory Bunsen burner for about 30 seconds. I'm not timing very well. Let's say that's about 30 seconds. So not hot, just heating it a little bit. And then to use, by the way, and you won't be able to see this probably at home, but there is some condensation. See the water vapor? It looks all steamed up here. So there is some water vapor condensating on that. Oh, I need the Bunsen burner yet. I'm not going to shut that off. So this isn't really hot. But what it says to do then is to take a piece of litmus paper. So there's a couple different kinds of litmus paper. There's blue litmus paper and there's red litmus paper. We want to use the red litmus paper, and I'll explain why in a moment. So this is kind of, it's not real red, it's kind of pinkish colored. And this says to, I'm trying to get just one, there's a whole bunch of them in here. I'm going to get this a little bit wet. I'm going to heat this a little bit more just because it's been a while. So this is my pink litmus paper, and I put it in the mouth of the test tube. Doesn't have to be very long. And I don't know if you can see that color change. It changed to a very blue color from that very pink color. I don't know if it's easy to see against the white background, but you can see that it turned blue. This particular litmus paper, the red litmus paper, is used if there's a color change that indicates that there's a base in there. Okay, so something that's basic. The blue litmus paper, likewise, is used to indicate the presence of an acid. So we know that there was a base, that this was breaking down into a base, or something that was basic was being emitted, or released from that reaction. The next thing, 1 minute, almost 12 minutes. The next thing it says, test for the formation of a gas. It does say to smell this, so please do write that observation, that strong ammonia smell. If you have cleaning ammonia, you know what that smells like. Ask your parents if you have cleaning ammonia, or like a Windex or a glass cleaner that contains ammonia, you can smell that same thing a little bit. Cleaning ammonia, you can really smell it. That's actually very strong. Be careful to waft, like that's pretty strong. It says test for the formation of a gas. Light a wood splint and insert the burning splint halfway down the test tube. Well, I have a splint here. I'm just going to light that on fire. I'm going to do a quick little, like I want to, again, because we didn't heat the, I'm kind of slow when I'm going through. These are just literally little wooden coffee stir sticks. I'm going to see what happens when I put this in here. I don't know if you could tell that. Looks like it went out right away. So think about, it wants you to think about what gas is being produced. So what gas is necessary for combustion, and obviously it wasn't that one because it went out right away. So it's obviously a different gas. And you might not know yet, but your observations that you write down right now are very important, because we're going to do this wooden splint thing for several of these reactions as we go through, and you're going to see other things happening with the lighted splints in different reactions, and I will guide you to kind of arrive at sort of what you need to. But for this one, make sure you write down in your observations that the wood splint went out right away. So there's some type of gas that's not supporting combustion, and in fact is smothering that flame out pretty quickly. Okay, that's the first three, and we'll watch for more videos to come on this. I wish you could be here and do these in person. This is really just, I think, just really a fun lab. But at least you'll get to see it and make some of those scientific observations on your own.